Hi, this is Brian Fogarty, and this is a video for Chapter 12 of the book Quantitative Social Science Data with R, second edition. So in this video we're going to do is look at something known as multicollinearity. So this is one of the additional assumptions that we make with linear regression. Actually, we make it with any type of regression, really any kind of multivariate analysis. Multicollinearity is essentially whether or not one or more of our predictors are functions of other ones. So are they collinear is another way of saying it. When this happens, then the standard errors will be larger than they should be, and some of our results will get all wacky. I have very infrequently encountered multicollinearity in the quote-unquote wild. But I think it might be due just to the data that I commonly use that I really don't have this situation. So where we see it, where I've seen it, is if we have variables that are really kind of measuring the same concept, but they're just kind of measuring different things, but they're really the same concept, then we'll find it. Students, when they're first learning this stuff, sometimes will find multicollinearity, but it often is the case that they'll put in two versions of the same variable. When you do that, then they're collinear because they're just two versions of the same variable. So again, I've not really found this to be that big of an issue or very common. Even if it is common, there's ways to fix it. There's really simple ways to fix it. So we're going to look at two things here. One, we're just going to do a correlation between the predictors in our model. So this isn't a test for multicollinearity, like a technical formal test for it, but I like to do this because it gives me a sense of the relationships between our predictors. We're going to use the corrr package. This is it from the tidyverse world, not tidyverse, sorry, tidy models world. We looked at this in, what was it, chapter 10? Okay. What's nice about it here actually is that we can do a bunch of predictors at the same time. So we're not going to save this as an object. We're just going to include it kind of in the frame. We're going to do SIMD and then select the select function. Again, that's like subsetting or picking or choosing or selecting our variables. So we're going to do employment deprived, % overcrowded, and then we're actually going to use urban, not urban factor, because I think we'll get an error. Let's double check. So to use correlation, our variable needs to be numeric. Let's just check real quick here. I don't think it's going to work if we use urban factor. Yeah, it's a character because we labeled it, right? So we're going to use urban. It's the exact same value. It's the same information. It's just that it's 0 and 1 instead of urban or rural and urban. Okay, so those are our three predictors. And then we're going to use the correlate function and say to use complete observations, complete.obs. All right, so let's highlight that. Okay, so I tend to look at the lower triangle, even though it gives us both sides of it, right? So I don't really see any issues here. We see % overcrowded, % employment deprived is 0.57, which is sort of moderate correlation, but it's really not something worrisome, I think, so worrisome meaning like if you see a correlation of like 0.8, or negative 0.8, so really the absolute value 0.8 or larger, then you might be like, oh, there might be an issue here. But we seem good. Okay. The test we're actually going to, the sort of formal test, is known as the variance inflation factor test, the VIF test. We're going to use a function VIF from the car package. So we just do VIF model 1, And then the VIF is going to give us values, and that tell us about how much shared variance is explained. And so the values themselves, the square root of them tells us how much larger the standard errors are because of collinearity. So let's run this. Okay, so what we're looking for here is it's very much a rule of thumb situation. Generally, the rule of thumb is that if the VIF values are 10 or larger, then we have multicollinearity. These are nowhere near it, right? So we don't need to worry about it. What do we do if we do find it? The simplest one is to remove the problematic variable. So, for instance, if percent overcrowded was 10.6, then we would remove that. Or if there's multiple and maybe they're showing up together, make a theoretical decision like what matters here, because it could be that one of these variables is a control variable. You don't really care about it. So there is a sort of theoretical substantive reasons for keeping or removing variables. Okay, so that's it for looking at multicollinearity. Thanks for watching. I'll see you next time.